Coders, welcome back to my YouTube channel where we solve DSA problems and we are solving questions in LeetCode 75 list. And let's see what the today's question. And yeah, let me take you to the screen. And now, so we have completed the questions from these two section arrays and two pointer. Now we are in sliding window, and in sliding window yesterday you have completed this question maximum number of ovals in substring of given length. Now we'll see maximum consecutive ones. So let's see what the question is. Question says कि given a binary array nums and an integer k, return the maximum number of consecutive ones in the array if you can flip at most k zeros. Okay, it means we need to find maximum length of subarray which contain only ones. Is that only that maximum number of consecutive ones means what? We are finding the subarray which contain only ones and it will contain 0, but that number of zeros should be less than or equal to k so that we can flip that case, that we can flip that zeros to 1 and we can take that length as that the maximum length we can record it and we'll take this. So basically what happened, 1 minute. Okay. uh, now what the best case coming in my mind is we can take, and let's say ki the best case, that's what I am talking about. We have array that given that is nums, that is vector int nums, that is our vector, and we count the zeros in that nums and that zeros are less than k. Then we can flip all the zeros and we can return the length of that nums, and that will be the maximum answer. Okay, and that's the best case. And now think ki if what I thought ki for I told this for the whole array, but what if key number of zeros is greater than k? So we need to find ki at what point is exceeds greater than 0, and we need to uh, drop some zeros, like where we have done that we have flipped that zeros to 1, and we need to take the next zeros so that we can find the where at what which subarrays have max length which contain less than zeros whose number less than k, a number of zeros are less than k, and length of that whole subarray is max, that we will find. And the naiviest approach is coming in my mind ki find out all subarrays and count zeros in that, count zeros and till zeros less than 0, I mean sorry, zeros less than number of zeros less than k, and if number of zeros less than k, then return that length and we'll store maximum length, max length. That's what the naive approach. But what I want, what but how much time it will take? Like finding out the all sub array itself take big of n square time. Then we need to find number of zeros in that sub array. It will take again n big of n time. So big of n. So basically it will take big of n cube time. And they have said ki slotlet, that is n value can be 10 raised to 5. So it is not allowing, it's not even allowing 10 sorry, it's not even allowing us big of n square, and we are talking about the big of n cube solution. So no worries, this is our what you can see, it is a naive approach, and through that naive approach we can go to the optimist, that we can optimize it. uh, First we will see ki what is the must here, ki subarray, we want subarray, and count of 0, yes, we want count of 0, but do we want to calculate the count of 0 at every time? Like we are just, if we're just, let's see ki I'm just adding 1 and just last separating 1, likewise just I'm just shifting my window, and in that case also, should I need to add, like should I need to count every time? No. So what I can do here, ki I can use uh, left and right pointer, where my right pointer will act as I'm extending my window size, and my left pointer will act as I'm shrinking the window size. And all these thing will work on a rule that number of zeros in that window should be less than or equal to k. If it is exceeding k, then we'll shrink it till the number of zeros less than or equal to k. And if it is less than equal to k, then we will start to extend it, because we want maximum number of consecutive ones, we want max length, so we will extend it till the condition satisfies. So through this way we can save n square time, and we can do this in big of n. And how we can do, let's see in the in question, like in code. Let me take that what I was saying ki, I want length, I want left and I want right pointer, so I will take here is equal to 0 and r is equal to 0. And uh, I also want to maintain the length. I don't want to maintain that r minus cl, that I was to take that length likewise, cause just I'm just reducing the complexity, cause sometime it can happen ki I have to take the r minus l minus 1 or r minus l plus 1, or r minus l only. So reduce that complexity and just get rid of all those thoughts, cause that is not important now. We just want length, so just maintain the length variable here. Length is equal to 0, and we want to extend r till the nums dot length, so we'll store that nums dot length in n, and nums dot size. And I just said ki we will calculate the number of zeros in that subarray. So for that, just say ki count 0, count z is equal to, right now it's 0, and when it is exceed the k, then we'll see what we, then we'll extend, then we'll shrink that subarray, because we don't want number of zeros more than k, that's why. And now let's go to, like let's see the algorithm that I was saying ki sliding window, let's shrinking and extending. While my I have to check while my right pointer is less than n, so that will be the condition here. While my right pointer is less than n, I will check ki if the nums at that right pointer, if nums at that right pointer is equals to 0. If it is 0, then what I have to do ki count of 0 greater. And as I am going, like as I am taking that nums at r, I have to extend the length also, cause let's say ki here I have example, let's take this example what I did it. Okay. Let's say I have 1 0 1 1 anything. If I'm checking this, then I'm thinking ki I'm checking in lane 1. If I'm checking 1 0, then I'm thinking ki I'm checking in lane 1 0. I'm checking from 0 to 0, then it is also lane 2. So while I'm checking, I'm extending my lane, like I'm taking lane plus plus, and when my nums r is equal to 0, I'm counting the count 0. And now I have to check ki count 0 is greater than k. If it is, then what I have to do, I have to contract, or we can see we have to shrink our left pointer, because we don't want to extend it greater, like don't want to extend it to k. It's not 0, it should be k. Okay. If my count of 0 is greater than k, then what I will do ki while my num set left pointer is equals to 1, till then just shrink it, cause we have flipped zeros to 1. So for that, we will check it till 1, we will just shrink it. And now when I will also check if my left pointer is less than 0, sorry, my left point, okay, it will also, okay, no, I was thinking my left pointer should be less than right, that I have to check, but it will, it automatically, it will be fine. Okay, that I don't need that condition ki left is less than right, and then nums dot el is equals to 1. I just need one thing ki my left pointer shouldn't be less than, left pointer shouldn't be greater than n. So I can put that condition ki my l should be less than n, and num set el is equals to 1. Till then I have to check, till then increase that left pointer. Now this can happen ki my l is less than n and num set l is equals to 0. If it is equal to 0, then what I have to do ki, if it is 0, then I have to flip it again. Like previously I have flipped it 0 to 1. Now I want to extend my array to the right, and for that I don't have number of, like I don't have uh, zeros, like though I can't extend it cause already I have flipped k zeros. Now I'm just flipping it last zero, like the zero at el index to 1, cause I'll, so k minus 1 zeros are flipped and 1 zero isn't flipped. So for that I can go to, like, and extend the subarray, and I can find the where is the 0, and I can flip that, and then I can take the length, and that can be the maximum length. So for that I'm just flipping it back. It means just I'm uh, going forward, and while this my k or my count z is minus minus, like count z I'm reducing because I reduced 1 0. And now what I want key here, my length was reducing, so my length also was reducing here, and here also my length is reduced in this block, so my length is reduced here also. And we'll go to the next, that is length is already plus plus, and our, let's say the right will plus plus in while loop only, so we'll do right plus plus, and we'll store answer is equals to maximum of answer and that length. Did I mention answer variable? Okay, I have to declare it first. Answer is equals to 0, and we'll go to next. I will return my answer variable. Yeah, let's check it. It is accepted, so just submit it. Yeah. So let's see the what's time complexity here. The time complexity for this is big of, time complexity for this is big of n, cause we are just traversing it once and we are just shrinking it. So it will be just what, big of n plus n, that is 2n, but generally we take big of n. So what is it? The time complexity for this is equals to big of n, and the space complexity is basically here we just storing these variables. So the space complexity is equals to big of 1. It is a, like it is a constant space complexity, so we are taking big of 1. Done. So yeah, so this was our solution for the question, that is the maximum consecutive ones. I hope you liked it, and yeah, bye.